Yes. So once again, welcome to Jagabandhu sir. He has already taken one of the sessions that is on fundamentals of speaker recognition. Okay, so today he is going to take another session, the second session, that is your spoken language diarization. Okay, so now session is yours, Jagabandhu sir. Now we can start. I have already given the permission.
1 second. Okay, thank you, Professor. Am I audible, no?
Yes, audible.
Okay, so thank you, Professor Satya, for giving a nice introduction. So today we will discuss about spoken language diarization. So it's actually somewhat high level. So why I am not able to change my slides? Yeah, it is somewhat high level. So if someone is not able to understand at all, kindly let us know. Maybe we can go slow. It's specifically my PhD work. So let's.
Jagabandhu sir, you have not shared the slide.
Huh?
Slide has not shared.
Okay. Let me share first. आपने परमिशन दिया था ना, मैंने शेयर नहीं किया.
Yes, permission has already given.
Okay, let's see. Oh, is it visible now?
Yes, now it's visible.
Yes, sir.
Okay, so we'll discuss about spoken language diarization. So it is somewhat high level topic. It's mostly one of the kind of applications area of speech signal processing, and mostly we can see like it is the whatever we have learned kind of on fundamentals of speaker recognition, and till now whatever you have seen in other topics. Maybe the mixture of all the things we can see here, and I think Dilip sir and all may have also told about deep learning and all, so we can see a full mixture of signal processing and deep learning in this whole lectures. And the thing is, if you are not understanding in any point, you can raise your concerns. And it is very recent work, spoken language diarization was not evolved much in the literatures kind of thing, and it was my PhD work. I can tell onto that, it is kind of course, it is like a lot of things are still there to explore in this area. Okay. So the overview of the talks will be as follows. First, we'll see what is spoken language diarization. Then we will see what is implicit versus explicit language diarization. Of course, we will define what do you mean by implicit and what do you mean by explicit. Then what are the challenges on implicit language diarization? Because I will also tell why implicit language diarization is preferable over explicit. Then humans language discrimination. So we will discuss how human do the language discrimination, and using such clues how we can design our models using the current state of art models and all to get better performance for language diarization. Then we will discuss about implicit language representations, then performance of language diarization, and what are the future scopes are there in these directions. Okay. So with respect to that, let's come to the first introduction slides of spoken language diarization. I think you people can see my full screen, or?
Yes, sir. We can see it, sir.
Yeah. So the spoken language diarization is a kind of task or a process where, like, given a code switch utterance, it will automatically segregate the monolingual segments present in a code switch utterance. Okay. So now if you see here in the figure A, there is a code switch utterance. What it mean by code switch utterance? Like the speaker kind of switches between the language in a given utterance. Okay. So now if you see the figure A, it is showing like one speaker is speaking in Hindi and English both. Okay. Now, once you pass through a language diarization system, so the system will give expected output as a kind of from where to where which language is present. So in a kind of other way around, you can tell which language comes when, as a tagline for language diarization, which language comes when. Okay, so these things will give by the rich transcription time marked byte, which is the output of language diarization system. Using that, you can segregate out the different streams. So first one is kind of the Hindi stream, second one is kind of the English stream. So this have lot of applications nowadays. So why actually this work is motivated? Let me tell some stories and motivations with respect to that. So if you see, like there are many applications your speech recognition, your translation systems, systems, and more specifically your that Google Home or Amazon Alexa kind of systems. When they come and try to deploy it in Indian scenario, they face lot of issue, because these systems are developed in mostly Europe or US, where mostly people use a single monolingual utterances. When they speak, only use only one language, and more specifically in English or their corresponding language. But when they come and deploy their systems in Indian scenario, they are drastically fails. Why this happens? Because Indians are by nature they switch language. Because if you can see, like when we use any kind of Odia sentence we are telling, so many of the English words or English phrases, okay, or English sub sentences we merge in kind of when we are telling. So this face a lot of issue on kind of mostly towards the ASR, automatic speech recognition, and also it also degrades the performance of other applications. So to tackle that, one way is to use a language diarization as a pre-processing element. Okay. So once you use a pre-processing system, it will give you different strings and you take it and process it differently. Okay. So that is how the motivations of language diarization systems. Okay. So now you can see, like the phrase is like अधिक जानकारी के लिए कृपया contact@spoken tutorial.org पर लिखे. So such sentences we generally use. Okay, but if you pass it through some ASR systems or something which is trained monolingually, it is very difficult to get the proper annotations from the such sentences. So to tackle that, we are using this. So like what are the possible applications areas? Like we have mentioned code switch ASR or speech to speech translations. Okay. So I hope most of you have understand what is code switch. Can anyone tell what is code switch sentence or code switch utterance? Anyone?
I think when we are speaking some in some languages, other languages, that some parts of the other languages is going to be mixed. That one or something?
Yeah. So in one utterance, there have multiple languages present. Okay, more than one language is present in a given utterance. Then it is known as a code switch utterance.
Like an English speech.
Yeah, English you can tell. Hmm? Okay. So now let's see. So the one way you can deal with that is like you use a automatic speech recognition system which is trained on global pronunciation model. Okay. So you may know, like in ASR automatic speech recognition, whoever are working, so there will be acoustic model, there will be a pronunciation model, and there will be a language model, correct? So how it works generally? So when we given a speech signal, when we get some features out of, we extract some features out of that, and that features we pass through first through the acoustic model, and the acoustic model give us some phoneme related posterior things, which phones are coming kind of thing. Okay, or maybe the single linguistic units. And then what pronunciation model will do, pronunciation model will have like, it is a kind of text model which will tell like phoneme to phoneme how they are combined to form subwords or words. Okay, so using that acoustic model and that pronunciation model, we are predicting the words. Okay, and that words, if you see how the multiple words are combined to form a sentence, that will be governed by the language model. Okay, so these are the kind of your pronunciation model and language model. Then finally you will get the whole decoded sentence. Okay, so but now you have a code switching, so you can't use only English or only Hindi or kind of only Odia kind of thing, pronunciation model or language model you should not use. If you use, then it will give a wrong output from that. Okay, so then what you can do, you can use a kind of global pronunciation model. What is global pronunciation model? Like you can see like what are the overall kind of union of the phone set of English and Hindi you will take and you model that. And similarly, the language model also, when you do, you pull out the all Hindi sentences, you pull out all English sentences, and you prepare the whole language model out of that. So that is how they do earlier. But the problem with that is it is very clear. You can think, suppose the way that English sentences are formed, the grammatical rule that used to form English sentence or English word are different uh, compared to the word formation or sentence formation in kind of the Indian languages. Okay, so in such scenario, that you will get a very heavy confusion on such systems, and it may be problematic on that sense, and it needs some careful investigations, and need a linguistic experts, and also you need a lot of transcribed data, and the problem may happen, no, if you use such things. So that may happen that the things may not available at all time. Okay, so like that linguistic experts may not be feasible, or maybe the that not annotated data may not be feasible in some language, and it is more happens in kind of the Indian scenario. If you see Indian scenario, India have lot of languages. Okay, at least 23 in the, we have like official languages. If you see all 23 official language, they also don't have like linguistically rich or kind of resource rich language. They are not resource rich like English or something. You will not get like kind of thousands of hundreds of hours of data to annotated data to train such models or such kind of rich models. So on that case, it will kind of give a problem. So that tells like instead of that, maybe we can use such a system which will use language diarization system, which will you first it will give like different monolingual ASRs as a front end, and then using the boundary language, boundary information and your monolingual ASR, you can get the final output like this. Okay, so this is what the motivations, if you see. So there are multiple categorizations we have done. So like framework generalization, flexibility, linguistic intervention, and inference latency. So the previous one, what we have talked is kind of dictionary adaptation method. What used that global pronunciation model is known as dictionary adaptation method. Okay, and the later one is like what we are proposing is called language diarization system. So these two are, if you compare, so framework generalization. So framework generalization means, suppose I prepare a framework for automatic speech recognition task. Will the same framework will be useful for translation task or only or other speaker recognition task or so? If you see, if you are using dictionary adaptations, then it may not be possible to generalize for other tasks. Okay, so on that basis, we are telling like if you are using language derivation system, it is easy to scale up for different tasks. Okay, so on that way, we are telling it is difficult for dictionary adaptation, whereas language derivation, it will be easy, that framework generalization. Next one is the flexibility. Okay, so flexibility is like, suppose I prepared a model in kind of Hindi English scenario. Can it be useful for any or can the same model will be useful or kind of adapted for other language pairs? Okay, suppose in Bengali English or some Odia English. But for dictionary adaptation, as it requires like linguistic knowledge and everything, no, it will be difficult for dictionary adaptation based approach. But where if you go for language diarization, it will be easy. Okay, so now comes to the third point called linguistic intervention. So linguistic intervention is a linguist person is required for designing such things. For a dictionary adaptation method, yes, we need a linguistic person who can carefully annotate the whole linguistics things, what is the phonemes and what is the words and how they are related. But if we go for language diarization based approach, these things are not required. Next, the inference latency. Inference latency means if we are going for a ASR task, if we are using dictionary adaptation method, obviously the inference latency will be medium because it may not take that much time, but language diarization systems required because language diarization is a external systems we are embedding in between the in the front end, correct? So it have a processing time. So that is the processing time will be high. So if you want to compromise with the processing time and you have you don't have actually the uh, proper resources for a language, then it will be good to go with a language diarization based approach. Now again, what are the other benefits? It's we are telling all things about the ASR perspective. Okay, so what other applications can be done with language diarizations? Of course, speaker diarization as a example, we can see like the language diarization also can be used as an independent application. How it can be used as an independent application? Suppose we want to give some language proficiency score, okay, to the news executives. So we will tell, suppose it's a regional channel, suppose it's a our Odia TV channels, okay, and as a our sentiment, and we generally tell no, the language should not die, okay. So we generally emphasize that the executives should only speak in Odia. They should not use any English words in between. Okay. So if the executive is speaking everything in Odia, then the efficiency or the proficiency of the executive is very good. Okay. So if we want to analyze such things, we can also use language diarization system to compute, suppose the diarization error rate as an objective measure to calibrate their proficiency. Okay, so such things also language diarization system can be useful. And similarly, if someone wants to learn some language or some kind of you want to learn some foreign language or something, in such cases also you can use your diarization system error rate or diarization error rate as a kind of performance or proficiency evaluation. Okay. So now when we are going for language diarization, now we have got enough kind of motivation why we go for language diarization system. Okay. Now when we go for any kind of language diarization, so what we need first? So first we need we should have to discriminate between the language, no? Then only we can know this language is present from this second to this second, and then other language is present from this second to this second. So we need to know the language discrimination. So what are the things which is required to discriminate between the language? I think you people may answer this question because already I think Murali has taken the language identification lectures, no? Can anyone tell, human or machine, what are the characteristics they take to discriminate between the language? Anyone?
The phonetic structure, the tonal structure, and
Okay.
how the specific word and which are pronounced differently in two languages.
Okay. So now from the figure itself, you can think, okay, how human first use to discriminate between the language. So when we
Hello, you are not audible. Yeah, some problem is there.
Hello, am I audible now?
Yes, yes, you are audible.
Okay, let me present and see. Okay.
Not audible.
1 second. Okay, I think I am here. Why it is not coming? Hello, am I audible? Hello, hello.
Yes, yes, audible.
Oh, okay, fine. Sorry, I think there is some internet disturbance. Okay, so now, what? Why is it may not be required to us now? Is my screen is visible?
Yes, yes.
Okay.
Yes, sir.
So yeah, okay. So when human try to discriminate between the language, you can see like here with language specific exposure, human learns these abstractions labels. What is what these abstraction labels seems like there is this kind of these are the kind of levels of informations human learns from the speech signal, okay, and then use them to discriminate between the language or kind of detect the language change kind of things, okay. So what are these abstraction labels? First is acoustic phonetics. Acoustic phonetics means each language have their specific acoustic patterns, okay. So like how the phonemes are generated. Suppose we tell no ka, kind of ka, kha, ga, but when in Hindi may not be there telling as a ka, they may have a different pronunciations method, correct? Or English they have a like A B C D kind of the phonemes, okay. So so that pronunciations different is captured generally in the kind of acoustic phonetic, how human pronouncing that phonemes or the linguistic units, okay. So that discriminations is given by acoustic phonetic approach. Phonotactic is how the phonemes are combined, okay, or how the distributions, not actually combined, how the phonemes distributions are. So acoustic phonetic tells how that is produced. Phonotactic tells what is the distributions of that specific phonemes. Distributions means if you see, if you take a set of sentences or kind of a story from Odia language or something, you can see that the frequency of occurrence of O will be high. Okay. Similarly, if you see some uh, your Gujarati, there are some oo kind of things will be high. So that specific phoneme frequency, if you see, so these are different with different language, okay, and that things are captured in phonotactic information, okay. So then next comes to the prosodic. Prosodic is like this, you are, I think rightly mentioned, Shankar, someone like this tonal informations and such things, no? So how the intonations and tonals, how like your okay, so how the frequencies or kind of the fundamental frequencies are varying. Okay, so these are known as your prosodic informations. Okay, that also differs in with respect to language. Then comes to the words. Yeah, words are also different with respect to language. The word formation ways are different in different language. Then comes to the syntax. Syntax is how the words are combined to form language. So with exposure, so with human knows the language, the exposure increase, human able to give the discriminations by learning these abstraction labels. And if you see a kind of infant or a kind of a person who is newly going to somewhere, he will not able to hold about the grammatical details. Mostly he able to differentiate between the language. Mostly he use acoustic phonetics information or some phonotactic information. Okay. So then if we see,
So,
these are the, yeah.
so are you on that how human identifies the different language? That's the slide where human brain is there and the different features. Because I am showing that I am showing the significance of spoken LD slide. Is
Oh,
everyone?
oh,
Yes,
where
yeah,
is it?
also, I'm also.
Oh, let me then reshare it if that is the case.
Yes, yes. Stagnant.
Oh, this one you are seeing?
Heading
Sir,
is
yes, sir.
significance of spoken LD.
Yes, sir.
Oh,
Where you were told that GFS,
okay,
TFS,
okay.
TFS.
Okay. Is it now visible?
No, sir.
What happened?
Individually, just share that one. I think whole screen is not going to be shared. I think.
Okay. Why options I am not getting to share whole screen?
No, that option is now not there in Zoom also. Means here is also I am not getting that one. I don't know whether that has wiped out.
To create the whole screen, to share the whole screen, that
Now
option I am
previously
not
that was
getting
there.
now.
Nowadays that option is not there. If you
So,
want to play that music also again, you have to share multiple screens. Then only.
Oh. Oh. No,
But
it started no sometime before it was working. Is it the some update happens or something in between,
yes, sir.
and then I go out from that? ऐसा हो सकता है.
I reshare that one otherwise.
Okay, let me do that. Something. Now is it visible?
Yes, sir. Yes, sir.
Let me do like this only and work, because that may happen something wrong. Okay. Now let's see. Okay, so now we have discussed about what are the informations we are learning, okay, to discriminate between the language. Now, how to learn these informations and how machine can learn these informations to discriminate between the language, okay. So if we come to the machine, so mostly it can do in two ways. One is implicit way, another one is explicit way, okay. So what do you mean by implicit and what do you mean by explicit? So implicit means by the word itself, given the speech signal, the machine has to derive everything on their own. We will not give any hand holding or any help to machine. Okay. And it will derive on its own, and then it will tell like which language comes when, or like how to do the language discriminations with respect to that. Whereas in explicit way, we will specifically tell along with the speech signal, we will give some extra hand-holding informations to the systems, like the phonemes or their grapheme labels, okay, and or the phoneme posterior values or grapheme posterior values, okay, such that it will take some phonotactic informations to the system, and with respect to that, it will do the language discriminations. Okay, so is it clear what is implicit and what is explicit?
Yes, sir.
Okay.
Yes, clear or not?
Okay. So now, as mentioned, like I think you people may have discussed in kind of language identification. Maybe Murali has discussed. So many approaches. Many people use MFCC, CNN, RNN, transformer, and like early days, phoneme posteriors, bottleneck features, engram posteriors, such things. Okay. So this phoneme posterior, phoneme boundary, bottleneck features, engram posterior, etc. comes on the explicit approach, whereas in implicit, directly from speech signal, which is MFCC, your convolutional neural network, recurrent neural network based structure, or convolutional neural network transformer based structures. These are your implicit approaches. Okay. Now, what we are claiming here, so implicits are preferable over explicit. Okay. Why? Because if you see the flexibility, again, it comes to the flexibility, language, linguistic intervention, and inference latency. So flexibility, if you see, uh, we don't want to take any kind of external evidence with respect to the phoneme sets or language specific things to the system, give to the language specific things to the system. If we give, then what will happen? No, it will be not flexible. It will be only possible for that language pair. If other language pair, we have to design it separately, correct? So on that is how the flexibility is difficult in case of explicit, and implicit it is easy. Linguistic intervention, obviously, if you are giving extra information, linguistic information, you need linguistic experts. Here it is nil. Inference latency, obviously, it will be less in case of implicit LD compared to explicit LD, because explicit LD, it requires a special care with respect to the external help. Okay. So that is how the implicit is preferable over the explicit. And in Indian scenario, mostly as all the languages are resource care in nature, so most of the cases for Indian scenario, if you want to make the language diarization system to work, you have to prefer the implicit approach over the explicit. Now, when we are going with implicit approach, what are the problems may come? Okay, and how we will tackle that problem. Now, if you see from this figure, in first case, a single speaker speaking two language, Hindi and English. Okay. The other case is, second case is like two speakers are speaking English. Okay. Now in the second case, if you see, it is showing some spectrogram plot. Maybe some of you may know what is spectrogram. So you can see there is a language change here, and you can see the spectral patterns has no change. Whereas if you see when there is a speaker change, there is a clear change in the acoustic pattern. Okay, in the spectrogram, it is visible. So it is giving a clear change. If there is a large literature available on speaker diarization and speaker change detection in. So, and in language, and other hand, like language diarization and language change detection, there is no literatures are very less, or kind of very little literatures are, or very few literatures are available. Okay. So now you can see that as it is giving a discrimination clear, this maybe you can think like it is point-wise matching, okay, and giving a kind of contour. Okay, it's known as scale divergence contour. So you can see the contour is giving a peak around the change where there is a speaker change. Similarly, if you use the same algorithm here, you will not get a language change over here. And you see the contour is kind of more or less equal, and it is not giving any peak with respect to this, because the pattern is almost similar. And why it is happening? Suppose I am a speaker and I am speaking both Hindi and English. What will happen now when I produce this? The continuity not changing. My vocal tract system is only adapting to other language. Okay. So in that case, if you see the acoustic phonetics, okay. So like when we are continuously speaking, no, when we are speaking two language, so when it comes to the phoneme production, so the phoneme production has no change in between the language. That is why we are not able to characterize this using the acoustic patterns or the implicit way. Okay, so that is the challenging way, and we will see how to come out from that. And that is the one challenge. The second challenge is, in case of speaker, generally, if we see a kind of speaker diarization data set or kind of speaker change detection data set, they have a durations of each speaker segment. No, if you see, that will be very high. Okay. And in this case, if you see each speaker's the amount of data available is quite balanced. Whereas if you come for language code switch utterances specifically, you can see the language are the duration of the language, of a specific language, the segment duration of a specific language is skewed. So the language one has a high uh, duration, like monolingual segment duration, compared to the language two. And you can see the durations is very less as compared to speaker. So it's like more than 15 seconds, correct? Whereas in this case, it is like around 1.5 seconds and 0.5 seconds. And if you see the balance between the L1 and L2 in the training set, it is 74:26. Okay. So this tells, like, the speaker diarization, whatever the literature is available, you can't directly import it to perform language diarization. So you need some special treatment to prepare the language diarization systems. Okay. Then comes to the comparison between implicit and explicit, because the language identifications, what is happening till now, mostly they prefer explicit approaches. Okay. So explicit approach requires linguistic expertise. And if you have the linguistic expertise, it is good. You go ahead and prepare the system with explicit. But if you don't have, then there is a problem. Then how to do that? That is the question of this work. Okay. Now, if you see, if you are using explicit approach, some phoneme posteriors, you can get a clear peak at even in the language change. But when you don't have that, you are not getting it from that when we are using implicit approach. Okay. Now, with respect to that, how we have tackled this problem, we come up with some first, like, first we will see how human is doing that. Okay, is because human is not using any kind of linguistic expertise or something, no, or kind of the grammatical rules. Even we don't know the grammar or don't know the phoneme distribution of a language. By listening that, we can able to tell, like, this is a different language and this is a different language. Okay, even though we don't know the grammar in detail. Okay, so with respect to that, so first we thought, like, how we'll see, like, we will compare how human is doing speaker change detection and language change detection, and can we get something from that, and how we can incorporate to the computational framework. Okay, once we incorporate to computational framework, then we will see there are mostly inspired from speaker diarization literature. There are the ways, different ways they do kind of diarization task. Once we get that representation, we can use with these frameworks to get the language diarization results. Okay, or to perform the language diarization. Now, let's comes to the implicit language representation. How we will get the implicit language representation, which can able to give a proper discriminations. Okay. Now, for that, we have performed a human subjective study where we have done language versus speaker discrimination. So for that, what we have done, no, language change utterances, we consider some 32 language pairs come from so 32 utterances from 10 language pairs, and we consider some Hindi English, Bengali English, Telugu English, Tamil English, Bengali Assamese, Bengali, Assamese, Tamil Malayalam, Tamil, and Malayalam utterances. And speaker change also we took like some 15 utterances. Okay, and we make it in 5 groups. So NVF 10 is, we consider this NVF is number of voiced frames around the change we take. Okay, so it will be 10 means, like, it will be very small duration. Then we are continuously increasing the duration around the change, 20, 30, 40, 50, and then 75 frames. And this is showing, like, to avoid the abrupt truncation. So we use some Gaussian masking to get, like, because if we cut from the speech signal, directly, by taking some 10 voice frames, it will be very abruptly listened. Okay, so that is why we use some Gaussian masking to that, such that it will be smoothly come out from the speech whole utterance, around the change point. If we put such things, so it will be smoothly come out, and you can use it for, and it is easy to listening, and you can do listening experiments easily with these utterances. Okay, so we have around 2 sessions we have designated mostly for this, and we have collected the response from 18 listeners. Obviously, we have created a graphical user interface on the from using that, and we presented the utterances in random order. So 2 sessions, one is for speaker change detection, another is for language change detection. And out of the listeners, 13 are male and 5 are female. And then what are the informations we have collected? Language comfortability, language or speaker change predicted, then their response time and the number of times they repeated. So we asked, one utterance is given, so that utterances you can repeat multiple times. Okay, and you have to tell, is there present a language change or is there present a speaker change or not? Okay, so on that basis we computed some performance measures called detection error, response time, number of time repetitions, and then temporal durations irrespective of language comfortability. So then language comfortability with only with NVF 50 and 75. We will discuss why we have done that. So now if you see this figure, this is the outcomes what we got from all 18 listeners. Okay, so first surplus tells like detection error rate of language and speaker. Okay, so if you see the language case, humans are not able to predict the language edge confidence as speaker. Okay, so you can see the detection error is less in case of speaker, and language it is high. And when we goes on increasing the the duration, okay, around the change point, if you see the two distributions are coming at par, like coming together kind of thing. So how we calibrate that with the app statistics score? Okay, so this app statistics tells how close, sorry, how different are the two distributions are. Okay, so that is given by app statistics scores. So now if you see the app statistics scores is going down, that means it tells like with increase in number of voice frames, the human, the confidence in human to discriminate between the speaker and the confidence in human to discriminate between the language are coming to equal when we're increasing the number of voice frames. Okay, so that tells, as compared to speaker, human may require more neighborhood informations around the change point. Okay, so compared to speaker, we may need more neighborhood information, okay, to extract some kind of features or some representations. Okay, then the second, it also the similar information it tells, because if you can see the response time and number of repetitions, so you can see response time is higher because the people are confused in case in the smaller duration case, so they are playing multiple times. So that is why response time and number of repetitions is higher in case of smaller duration, and it is going down with with increase in the number of voice frames. It tells like your human requires more neighborhood information. Okay, then the next case is language comfortability score. Suppose a human knows that language. Okay, so 0 means human are not comfortable on the such language pairs, but in 3 means humans are comfortable on that language pairs, means human knows this. Okay, so in that case you can see if human knows the language or human has a kind of exposure to that language, then human can able to better discriminate between the language. Okay, so with respect to that, it seems to extract from machine, when we are seeing like machine to extract the language representations to perform language discrimination, this representation extractions requires 2 things. One is as compared to the speaker, okay, or contradicting to the speaker. So language may require more neighborhood information and prior language information. Okay, so these two things are required. So how we can include this to the machine? Now we can see earlier what we are showing to you, that the curve is coming equal as kind of thing. So that is actually the A figure, where the Hindi and English, if you see the representations, if these are all vectors, no, if the vectors you can project to a 2-dimension and you want to plot that, these 2-dimensional figures, plots are kind of overlapped with each other. That is why they are not able to discriminate between that. Now, compared to A, B. B is what? We have clustered that. Okay. And after clustering, we told like these are our virtual phoneme sets. Okay. Then with the virtual phoneme sets, you tell us like the how it is related to this virtual phoneme sets. Okay. Now the relations what we are getting, that we are telling is a kind of our representation. And if you see this representation is a better discriminations. Okay, so this is one way called U vector. Okay, then we further improve it called A vector, adapt vector, and then the further these are all using only zeroth order statistics. When we increase more like first order and second order statistic, we embed to that. It is known as I vector. And then further this is goes to X vector. The X vector is a neural network based framework. Okay, so TDNN framework, whereas all BCD are the statistical frameworks. So you can see, so the starting from A to E, the discriminations increases with the representations. Then we saw with respect to the statistics, this is in one file. Now the statistics has been seen with respect to like the whole training data we have taken and testing data, and we are showing 4,000 in 2,000 pairs. So 2,000 between language and 2,000 within language pairs, and we are showing the discriminations between them. You can see the equal error rate as an objective function we have used. So you can see the objective values are error values are reducing. Okay, so that means it tells the what we are telling in implicit representation, it is not feasible if you carefully embed our what we got observation from our human subjective study. After embedding such in the computational framework, we can able to get some 3.6% error, and which is giving a comparable like discriminations between the languages. Now we will use these representations. Obviously, this is something with respect to the explicit representations, what we are getting directly from the linguistic knowledge. Okay, so that is telling some 0.05 is the best compared to some 3 point something what we are getting there. So these are the comparison between the implicit and explicit representation. At least it is not able to beat the explicit representation, but at least it is at par to the explicit representation, what representation we got through the implicit. Now using the implicit representations, we try to do the language diarization tasks. So in our case, we have 3 frameworks we have proposed, okay, to perform language diarization. 2 are the traditional frameworks, and third one are the kind of end-to-end framework, okay, which is like more that with respect to the recent trends. Okay, so the traditional frameworks are the fixed segmentation framework, which is still largely used in case of speaker diarization. Okay, so what and there is a difference compared to their speaker diarization. What they do generally voice activity detection, and then they get like a segment level utterances, whereas we do voice activity detection in the frame level. Okay, now once we get the number of frames, then which are the voiced frames, and these voiced frames are used to do the fixed segmentation approach. Okay, then similarly the voice frames are used to do change point based segmentation. So we'll see how the fixed segmentation and change point segmentations are different. Okay, so fixed segmentation is like we are telling about the duration, neighborhood duration required to discriminate between the language, correct? So in fixed segmentation, the segment duration is always fixed. Okay, and that segment representations we are getting, and with respect to that, we are giving a label to them. Okay, that is known as fixed segmentation. Change point based means like the change point we will first see tentatively we will get the language change point, and once we get the language change point, with respect to this change point, we will take their segments and then we will cluster them, and then we will give the labels. Okay, which one is comes to which language it will give, and finally it will give the output RTTM. And if we see the end-to-end model, so end-to-end we will combine all, like voice activity detection, your segmentation and clustering, all will be together, it will do with a joint loss. Okay, you can see here speech activity plus deep clustering plus classification, all will be done in a end-to-end framework, and it will give a output RTTM. Okay, now you can see here in this figure. Okay, yeah. So you can see here as compared to in the first case, Hindi and English, and this is the ground truth level. This black color are the ground truth level. Hindi and English language is coming. So, and this first one is the fixed segmentation. The using the fixed segmentation, the predictions were is this one. You can see with respect to black, mostly it is able to predict, but the problem is happening in the boundary region. Okay, so in the boundary regions there is a mismatch happening. That is why the error is high in case of fixed segmentation. So that is why we thought like we will first do the change point detection such that the boundary we will get very clear. Okay, and then we will do the clustering such that the boundary area errors we can minimize with respect to that in case of language diarization. Okay, so motivating from that, you can see the if compared to fixed segmentation, the change point segmentation based diarization has a better performance. Okay, in this figure, and then statistically you can see there is a diarization error rate and Jaccard error rate in both the cases with respect to implicit and explicit framework. So you can see when we are start with fixed segmentation based approach, we have an error called 17.58. Okay, so there is a difference between diarization error rate and Jaccard error rate. Maybe I will tell in the further slides. I think in the initial slides we have discussed about the class imbalance, correct? So primary language is very high compared to the secondary language, the duration. So with respect to that, no, diarization error rate is give a kind of wrong interpretation. Okay, so it may happen like no, like suppose 80% only primary language is present. Okay, and 20% is the secondary language is present. Okay, so if the system is biased towards the primary language, so what will happen? The secondary language is will not predict it itself, will be not predict. Suppose out of 100, all will be predicted as the primary language. Still, we will get 80% performance. And by seeing the performance, we will tell, yeah, 80% we are getting is a better performance. But the system is totally biased towards the primary, and the secondary language is not at all predicting. So that is not a fair treatment, correct? So on that basis, this Jaccard error rate is a balanced approach, okay, which is giving equal weightage to both the languages. Okay, so with respect to that, you can see the diarization error rate and Jaccard error rate are not same. That is high. So that tells our data are skewed towards one language. Okay, so that is how like you can see. But irrespective of diarization error rate and Jaccard error rate, from fixed segmentations to change point based segmentation, the performance improved and end to end further improved. Okay, and similarly it happens in the explicit also. Okay, so you can see though the fixed segmentation in implicit and explicit is better, change point explicit is better, but when we come to end systems, okay, so our implicit able to outperform the explicit systems. Okay, so this all what we have done with a synthetically generated code switch utterance. Okay, so this experiments what we have shown, it has been done in a synthetically generated code switch utterance called Hindi English pairs. Okay, Now we have extended this to another three pairs which are kind of practically available. So Gujarati English, Tamil English, and Telugu English. And as I mentioned, no, that we have a skewed distribution. So with respect to that, when we perform the experiments, we see that the performance is very highly skewed for that. You can see there it is 4.5 point. We are getting the diarization error rate. It suddenly increased to 22. And Jacquard error rate some around 20 we are getting. Here it is goes to 60.4. Okay. On such scenario, we come up with a technique called self-supervised language representation. Okay, so what do you mean by self-supervised language representation? So it is a kind of web-to-web based approach where we train with 10,000 hours of data. Okay, so we train the neural network with a 10,000 hours of data where they don't use any kind of label. It will just predict the masked replay. Suppose when we are giving the speech signal, we purposefully mask some part of that. Okay, and that masked part is predicted by the transformer. And once the masked part is predicted by the transformer and the actual part, what it have, we compare between them to update the neural network weights. Okay, so that is how the network, that is how it is known as self-supervised, because we are not using any label. So the self means like same signal itself is using to learn the parameters of the neural network. Okay, so that is why it is not known as a self-supervised approach. So within the self-supervised approach, we try to learn this framework, okay, that CNN and transformer framework, and that is named as this A block. Okay, so once we train this A block, okay, then another condition we have added there, this masking duration we purposefully put like the minimum duration will be around 320 milliseconds, such that it will be a tentative duration of a syllable or word, such that the system will capture while training to predict at the word level. Okay, so virtual word level, not actually word level. So it will predict the representations at the word level. Okay, so once we take that and then we use our data set, that skewed data set, no, and then we fine tuned this. Okay, and when we fine tune this, the earlier the problem was like we can't train it, it may go towards the only one language because of the language durations is very small in case of secondary language. So it may be chance that it can be skewed towards the one language. But now, as it is already learned a lot and it is know the word level variations, so there is a very less chance that it will be skewed towards the one language. Okay, so on that basis, we kind of fine-tuned this framework. Okay, so once we fine-tune this framework, the representations we take from this C. Okay, so from C block, we are getting the representations. It's known as self-supervised representations. So if you see, earlier we are using the X vector representation, and we are comparing here with our self-supervised web-to-vec representations. You can see with a smaller duration. Okay, with a smaller duration, because if we take higher duration, because of the segment duration is small, if we take higher duration, the problem with what will happen now, the smaller durations will be merged out or smoothed out such that it will give a error in case of diarization. Okay, so that is why the problem we faced like 60% Jacquard error rate we got. Okay, so due to that, we need a kind of representation which will give better language in the smaller duration. So that part is resolved using this self-supervised representation. Okay, so you can see compared to A and B, the A have better discrimination. So if you see 29.2 what was earlier, it reduced to 14%. Okay, and other language pairs, it has been improved similarly, some 5.05, 7.1, 17.5 and 13.5 respectively. Okay,
Sir,
yeah.
so can you tell about WL and BL? What is that?
Okay, so WL is your within language and between language. Within language means same language, you are seeing the what is the distance kind of thing. It is actually likelihood here. So how likely are the within language? How between language means like two different language, how likely they are. Okay, and we are seeing these two distributions. Getting
So
it?
here, yes, so that's why the error is high in the between language, because the change is happening. So it is not
Yeah,
able
between
to.
language, the likelihood will be less, correct? These are likelihood. Likelihood value is less, no? So it is
Yes.
going more towards the up, correct? And this is down, correct?
Hmm.
And similarly in the cosine similarity also. I think last time I was discussing about cosine similarity, correct? Hmm? Okay, so on that basis you can see so how the things are improving. Hmm?
Yes, sir.
Okay. So now with respect to that, when we evaluated the performance for fixed segmentation and change point based approach, we can see this with self-supervised, the DER and JER is improved. This A is using X vector and B is using our web-to-vec representations. You can show like the performance is improved. Similarly, then finally we come up with a end-to-end framework which will take this web-to-vec features or representation as input, and this is a clustering block, and this is the segmentation block, and this is the total loss with respect to your clustering, segmentation, and here we have used third class as the voice activity detection class. So the all three losses will be optimized together, and we can see like the performance earlier it was giving 60.4. Okay, using web2vec framework only fine-tuned one, the performance is relatively improved some 39%, and the error decreased to 36.8, and the final one is like 21.8 as a Jacquard error rate, and which is 63.9% improvement is compared to the earlier X vector one. Okay, so on this way you can see here once you extract the self-supervised representations. So in the earlier case, it was fully, you can see the silence part is clustered differently compared to the primary and secondary, but the primary and secondary are overlapped in case of X vectors in the practical dataset case. In the only considering the web2vec pre-trained, you can see there is a orientations of the black one is one side, green one is another side, and the silence one is another side. Then with a teacher role, using this as a teacher, we further fine-tuned them. Okay, so you can see this is like improved. The black one is got one side, green one is another side, and the blue one is another side, and it is further improved here. So this is the final one what we ended off like with a language diarization error rate of some 20%. You can see the confusion metrics as well. So it is for X vector based approach, the secondary language is not at all predicting. Okay, it's just using as a voice activity detection. Whereas when you use like web2vec fine tuned, it is improved. You can see 63.9, 74.1, and here 75.5%. Okay, so you can see the final table. So we start with a diarization error rate of 30.31 and 54.71, and it can be ended with like 11.2 and 21.8. So this is how the final conclusion I can tell. So human requires more neighborhood durations and prior language knowledge to discriminate language compared to the speaker. And the similar things we have incorporated, okay, through the computational models, and we saw the performance is improved. Change detection based segmentations again further improves the language diarization performance. Then the self-supervised representation able to help us to extract the representation in short duration and also give better discrimination ability. End-to-end framework performs generally we have seen the performance is biased towards the primary language. That is why we got 000 because of the skewness of the data. Then we saw like this, if we use self-supervised end-to-end framework, it can able to further improve that. Then the performance of implicit framework is kind of at par with the explicit what we have finally got the results. The future is like now whatever we have done, it's mostly a single speaker speaking multiple language. Okay, so if you have multiple speakers speaking multiple language, like a parliament speech or something, if you want to summarize them, then you have need a kind of careful investigations on that line, like intra-language speaker change, how we can do that. And in our case, we know the language by prior, so that is why we can able to model them. But if you don't know the language present in a utterance, on such case, how you can do so something like a universal language change detector or some universal language representation extractor, something you need. So such things maybe can be explored in future. Then the third case is as we are considering only single speaker, so we are not bothered about overlap language segment. If you have multiple speakers speaking language, no, so there have a chance of the language may overlap some cases, because two speakers may speak in the same time. So then maybe in different language, so there will be a language overlap case. So how to deal with such cases? Then of course the practical data set for studying all these kind of things, no, need to uh, kind of create a practical data set for that, and with all the metadata available such that the studies can be performed in future. So these are some publications what we have till now. So maybe they are available in public domain. If you want, you can go through it. So that's all from my side. If any questions, I can take.
In between two languages, the duration is needed. I mean that when we are changing the speech, I mean from one language to another language, we need a gap between them, or we need a higher duration of both the language and the secondary language which is spoken.
No, we don't have to do anything. See, whatever the language is there, it is there. So when we are doing some backend processing, so at that time, that is up to us how we should process it. Okay, will we take a segment representations when we are extracting? No, will we take a larger window durations to extract that representation, or we will use a smaller durations, like the like you are telling, no, what is that, resolutions you can increase or resolutions you can decrease. Okay, so if you take a higher window size, the resolution will be poor, and if you take a smaller duration window size, the resolutions will be high. Resolutions high means it will be better if you have a smaller segment duration. If the secondary language duration even is a word, single word kind of thing, if you have a kind of better resolutions, you can able to get the better better error rate or better performance. But on such cases, the trade-off may happen, like when you are deciding about the duration, the language representations what you are extracting from that duration, no, should have sufficient enough discriminations between the language, or else that may not help you. If there have no discriminations, because that human tells, no, that human need more neighborhood information when coming to discriminate between the language. So that is the trade-off part what we have seen, and we saw like that, like if you are using the traditional X vector based approach, it requires more duration, but it fails when the your because it requires less, then you can only do the things with less resolution. If you do with less resolution, if there will be a smaller segments, it will be faded off and you will get very high error. And at the same time, if you use our self-supervised representation, what we have derived or proposed, so that can able to give you in very smaller durations as well, and you can get very better resolution, and you can able to improve the diarization error.
Okay, so in X vector case we have to take the higher window size to discriminate that. Discriminate that. And
Yeah,
and
yeah.
in self yeah, in web to web one, we if we use the smaller window size, it will also work. Okay.
Yeah, yeah.
And in how that the percentage error is conquered in web to web, because it is trained with large number of data, inbuilt data. That's why it is already known the nuances. That's why it is able to identify the secondary language, even if it contains much number of less utterances in the much less percentage in the
No, it
utterance.
depends. It depends on the once you have better representations with smaller duration, you will able to process it with higher resolution. Correct. If you are able to have put it in higher resolutions, obviously, even it is a smaller segment or something, you can able to better predict it. Correct. That is how.
Okay. So X vector one, the resolution is low. That's why it overlaps between
Yeah,
them.
correct.
Okay, sir.
I have a question, sir.
Sure.
Okay, I found out that you put it on that feature roadmap about the overlapping of languages. There was one languages from Africa, precisely Nigerian, called Hausa, that is mostly speaking in Nigerians and part of West African. It exhibited this overlapping speech during lively exchange or debating. But you said it's a future roadmap. It means that some work has to be done on that one. But the question here is that there are some other languages such like Igbo, Yoruba, Swahili, and Zulu that uses non-verbal sound. They are said to be tonal languages where pitch and tones play a crucial role in meaning. So I don't know, how do we go about these issues of non-verbal sound in languages related to
See, when we
spoken
are
language?
when we are coming for any kind of web kind of self-supervised representation or such things, no, it will by default taking care about your tonal and all kind of things. Okay, because when we are comparing between two languages, okay, so and you are discriminating it at a kind of, because the self-supervised representation what we have shown here, no, so it will able, because it's not using any language label or anything when we are doing the pre-training with so maybe you can use your languages whatever you have, you craft on multiple language and you train such a representation extractor, okay, which will predict the masked representation at a kind of word level. Okay, so if you take a word level, no, so obviously your tonal things and all will be incorporated on that, correct? And then if you take that representations and then fine tuned with some of your labeled language, obviously you can give a better discriminations between them, correct?
Oh, okay, sir. Okay, sir.
Any other questions? Isa? Isa Hassan? Any questions from your side? My question is.
Sir, one more question I have. So in that explicit one, I mean, that is the old model where we use that Gaussian posterior to map the the phonemes to the MSCC features. Is that correct? So this method is not good because there we have to use the whole, we have to design the whole linguistic and grammatical part by ourselves. That's why it is not better.
It's not Gaussian posterior. Gaussian posteriors are different. This linguistic one are like phoneme posteriors.
Oh, phoneme posteriors.
Okay, so we generally what we have shown here, it is again a state-of-art neural network-based grapheme posterior representations. We generally told as grapheme. Grapheme means like again the letters. So with respect to the English letters and Hindi letters, they have the model available. So from that we are taking the posteriors, and this to train that you need know all the transcribed data and all, correct?
Yes, sir.
So
Yes,
that
sir.
is why it is bad. And of course, like with implicit also, we are able to catch their performance. So we don't have too much worry on that.
Okay.
Okay, any questions? Like Akashdev? think any questions are there. Okay. So thanks, Jagabandhu sir. So we'll see if any I think I don't know. Morning also 50 students are joined. Now only 30 students. 5-6 minutes left after this session.
Okay.
Anyway, so if anyone will be interested from mainly from this African continent, definitely they will contact me and I will also contact them. Take the
Sure,
feedback.
sure.
And then we'll connect like this. Okay.
Yeah.
Once again, thank you very much.
Okay.
And tomorrow there will be no session, Saturday and Sunday. Again on Monday we'll meet.
So happy Raja to all.
Happy Raja to all. Okay, thanks. Okay, I'll call you
Happy
later.
Raja.
Okay. Thank you.
Happy Raja. Bye.
Thank you, sir.